Greetings and welcome, friendos. Mr. Waddy here, and my kids are building Anakin Skywalker's Star Lego set from Episode 3 in the kitchen. You might hear him in the background. Here we go. Going over last night's homework. Algebra 2.04, talking about characteristics of quadratic equations. We're really modeling is what we're doing, trying to write the equation of a graph given some particular information. And so we had a couple different ideas. If you know a point and a vertex, they recommended vertex form. That seems appropriate. And if you have a point and some intercepts, use the intercepts form. And now they don't always come out and tell you that it is an intercept that they gave you, but one of the ways you can always tell that it's an x-intercept is its y-coordinate will be 0. So p comma 0 or q comma 0, that is a clue to you. And so let's take a look at example 4. Here I have a given point. So I'll say this is x1 and y1. And here I have what is definitely my vertex. And so that's my h and my k. I'll plug this into vertex form as a result. So y equals a parentheses x minus h squared plus k. Plug in what I know and solve for what I don't. And so y, a particular y that works in this equation is 3. And a is unknown to me. And when 3 is plugged in for y, 8 must be plugged in for x. Minus h would be minus 4. And plus k, I could write that as plus minus 1, but just take away 1 probably makes more sense. And so let's PEMDAS this. 8 minus 4 is 4. I'm going to square that 4. I'll get 16 times a. And now I'm just doing some old school algebra. And so what I'm doing is I picked the equation of the quadratic that suited us best, and I'm plugging in what I know and solving for what I don't know. And if I know a, h, and k, then I know the equation of the quadratic, and it will represent all points on that graph, which is quite helpful to us. And so let's see. So I get a equals 0.25 or 1/4. So there's my a value. And so my final equation is going to be y equals 0.25. That makes sense because it's opening up. It's positive 0.25 because it's going up a quarter over 1. Actually, it's counting by 2's here. So up a quarter over 1, up 3/4 over 1, etc. if I was trying to do all my fancy slope tricks. And then I do x minus 4 squared minus 1. And so I plug in only a, h, and k, and then I have all combinations, the infinitely many combinations of x and y that make this equation true are represented by the points on this graph. Oh, lovely, lovely. And so that's the idea, right? You're gathering clues and trying to find a particular equation that makes it true. So here we go. In this case, I have a particular point that it passes through. And if you're clever, you'd realize, hey, that's your y-intercept. Although, since I'm using vertex form, that doesn't actually save me all that time. Even if I was to try to use that form, I wouldn't recommend it. And so vertex form, y equals a parentheses x minus h squared plus k. Plug in what I know and solve for what I don't. So negative 24 equals, don't know a yet. X would be 0 when y is negative 24. X minus h, so minus a negative 6 is plus 6 squared, and plus k is negative 12, so I'll just write that as minus 12. So I plugged everything in, and now I'm going to find the value of a. And so 0 plus 6 is 6, and you could probably have just calculated 6 squared right off the get-go, couldn't you? You're a clever one. I'd say you can. So let's see, add 12 both sides. And we're doing old school algebra. Notice two things were happening to a. It's being multiplied by 36 and subtracted by 12. And we do the order of operations in reverse when solving. So instead of PEMDAS, we're SAD mapping. Minus 12 equals 36a. And then divide both sides by 36, and it looks like a is going to be negative in this case, And tell you what, I'm going to write that as -1/3 because I'd be annoyed having to write 0.3 repeating. And so that's my a value, meaning this parabola is opening down. The fact that 1/3 is between -1 and 1, it's a smoosh as far as vertically concerned. And so now I can write my equation. Ooh. So let's see, y equals -1/3 abs x plus 6, because of the k, x minus the negative, it's always going to opposite the h value, and then k stays the same on the outside. And so there's the equation in vertex form. Excellent. Next one we're going to look at is going to use intercept form. So that's the y equals a abs x minus p. I said abs. That's crazy. Quantity x minus p, quantity x minus q. So parentheses, not absolute values. And so I can tell by looking at this that this would be the p and this would be the q. And this I'll call x1 and y1. And once again, I don't know what a is. And so this is how you could actually write the equation, right? If you gathered some data of something that had a quadratic relationship, I'd gather enough data that I could write the equation, and then using that equation, make predictions. And so that's the value of this. So when y was -2, x was 1. So everywhere there's an x, I'm going to plug in a 1. Minus p, minus a -1 is plus p. And minus q, which was 2. And so now I'm going to, I wrote p there, didn't I? It should have been a 1. All right. All right. Hey, look at that. It's kind of worked out on its own. And so let's solve for a. 1 plus 1 is 2. 1 minus 2 is -1. And so -2 equals -2a. Divide both sides by -2. And you can probably see where this is going. A equals +1. And now that I know what a is, and I know what p and q are, I can write the equation. Y equals 1, parentheses, x plus 1 times x minus 2. And so when I write the equation, I do not plug in the values of x and y. I leave them generic, so that way they represent all combinations. Right? That's the idea. Oh, we're doing good for time, but I shouldn't spoil that, should I? Let's see. Here we go. Write an equation of parabola in vertex form or intercept form. Well, I'm looking at this, and hey, this has a y-coordinate of 0, so that means that this is one of my x-intercepts, and this has a y-coordinate of 0, so I'm going to call that q. And then this looks like a particular combination, just a point. It's not the vertex, it's just hanging out on the curve. And so that's an x1, y1. And because I know my intercepts, I'm going to use intercept form. Plug in what I know. I so wanted this to be an h, but it isn't. X minus p, x minus q. So 2.25 in for y. Don't know a yet. X1 is 3. So in both of my x's, I plug a 3. Minus 0, that'll be easy, and minus 4. And so 2.25 equals a times 3 times -1. That's right. And 2.25 equals -3 times a. Divide both sides by -3. And I'm going to reach for a calculator. The one thing I can comfortably say is that it's a smoosh and it's negative. 2.25 divided by 3. So -0.75. And because that's between 1 and -1, this is a smoosh. Yeah, so it's going down 0.75 over 1 and then down whatever 3 times 0.75 is. Yeah, you get the idea. And it's upside down because it's negative. Just refreshing our thoughts on all of those things. And so now write it in intercept form with x and y as x's and y's. And so I'll have an x minus 0, which I suppose I could just write as x, couldn't I? And x minus 4. Tell you what, I'm going to leave it in this format, though, because I feel like it. And so there's question 19. The other ones are similar, and these ones you're making a choice which form you write it in. I chose intercept form because I had intercepts. I would choose vertex form if I was given a vertex. And the last kind of thing we did was using technology. So whether you have a graphing calculator, even a TI 85 calculator that I used to program video games on when I was in high school, that could still do this exact kind of thing, a quadratic regression. But I'm a fan of utilizing the pixels and resolution and colors that you happen to have on your Chromebooks, and so I'm going to use Desmos. GeoGebra's fine too, spreadsheets can do similar things. And so, in order to do this, did it ask for a format? So we made the scatter plot using regression equation. I'm just gonna use vertex form, I guess. Yeah. So y1 tilde instead of an equal sign, a parentheses x1 minus h squared, and then I notice I had to get out of the exponent there, plus k. And boom, and so now I've got a predicted equation, and then what do they want me to find? Oh, they want me to figure out domain and range, and also when will it hit the ground. And so nice thing about Desmos, I just click on it, and tell you what, I'm just going to do a real garbage screenshot here. That's good. Tell you what, I'll just scroll down here, I guess. Oh dear, what have I done? All right, and so when does it hit the ground? That is going to be the x-intercept here. So at 4.183, actually, I didn't even read what this was about, guys. I was just excited about data. Well, time t in seconds, a sponge. Oh, from a window cleaner. Wow, dropped it. Oh dear. 4.813 seconds is when that occurs. And then interpret the domain and range. And so this part of the graph didn't technically exist because we don't have negative time occurring. And this part of the graph doesn't exist because I don't anticipate the sponge is going to penetrate the ground. That would be crazy. And so the domain is going to be, well, there's a few different ways I could write it. Tell you what, I'll just write it as an interval here. 0 is less than or equal to x is less than or, oh, well, let's use t instead of x, shouldn't we? Is less than or equal to 4.183. And so that's the time at which it's falling, right? And so it falls from 0 seconds to 4.183 seconds. And then the range are the possible y values, and that occurred from, is that 280? All the way to 0. All right, so 0 is less than or equal to h is less than or equal to 280. And so that represents the possible heights of the sponge during its descent. And so, yeah, we can now write equations. We can make predictions, right? We could even say, you know, at what time would the sponge have been 75 feet from the ground when a bird was flying past it? And I could plug in, right, 75 for the y value and then solve for the x value. And all sorts of wonderful things that you can do. And so, so this was the general kind of setup that we were doing. Vertex form, if you knew the vertex. Intercept form, if you're given the two intercepts. And if you are given 3 points, I would recommend just doing standard form, y equals ax squared plus bx plus c, except given those 3 points, you end up having to plug in each point for ax, y and x. You write 3 separate equations in 3 variables, and then you end up solving for a, b, and c using substitution, elimination, or something like that. We're going to explore that later on in this course, but thanks for watching, Internet friends. Calc, you later.